this. 3x plus 4y equals -4. And then I have x plus 2y equals 2. When I solve a system of equation, I am looking to figure out where the intersection of these two lines occur. What is the ordered pair that it is a true statement for both equations? Oops, I'm sorry, I'm standing right in front of it. Okay. Now remember, sometimes you get an answer, sometimes you get no answer if they're parallel, and sometimes you can get an infinite answer if they happen to wind up being the same line. Okay, and that's where this goes for. So when you did this, remember you had, I think there was what, 3 different ways you can do it. You had substitution, elimination, or what was called linear combination. You guys remember those 3? Okay. Yeah. All right. So you had what's called substitution. Put the thing in for the thing. Kind of what it is, right? I would use this if a variable has a coefficient equal to 1. What's coefficient? Thing before the variable. Very good. The number before the variable. So if it has a coefficient of 1, it usually just means it says x. Because they don't normally put the 1 there because they're saving 8. So if that variable has a coefficient of 1 and can be solved easily solved for easily, with ease. Okay. Do you have to use one method versus another? Use whatever you want. It doesn't matter to me. Okay. Elimination. That was the other one. Elimination was also fairly simple. What happens here if you use what's called elimination, that means if you have the same coefficient in the 2 different equations, you could eliminate them by either adding them or subtracting them. So what we did was we would say this: if same coefficient, same sign. What I mean by that is it a plus or a net minus or a positive, negative thing? Yes, ma'am. That's called linear combination, and that's exactly what you would do next. The linear combination is when you do multiple things. So the linear combination is if you've got like a 3x and a 6x, you multiply the top equation by 2 and then you subtract. You're just a step ahead. Yes, ma'am.
So when the test rolls around, we have to remember how to do both.
Choose whatever you want to do. I'm just reminding you of the ways that you can do it. I have no worries about what method you use because it doesn't matter. As long as it works, what does it matter, right? So if you have same coefficient, same sign, you would subtract. And then if you have same coefficient, and this will all ring a bell once you see a couple examples. With opposite signs, bless you, you would add, bless you. And then, like you were just saying, if all else fails, then you would use linear combination. Bless you. You would use linear combination to create a version of elimination. Okay. So that idea of what's called linear combo you would multiply to make elimination. Again, think of it as if all else fails. There is no one right way. There is no one wrong way. If you want to use substitution for everything by dividing out and setting something equal to like y equals to whatever and substituting back in, that's fine. It'll take you forever because you'll have a lot of fractions. If you want to use linear combinations to use eliminations via subtraction by multiplying by negatives, that's fine. You just got to watch your signs, your SIGNs, not your SINs. So little things like that. Again, you have all seen this. It's just a reminder. Yes, ma'am. Yeah. You just have, if the coefficient is not equal to 1, you got to make it equal to 1. So if you have like 2x, 2y, and a 6, divide everything by 2 and then substitute, by all means. There's no problem with that at all. So if I go back to this one, right away I can think of a couple different ways of doing this. I could get x by itself in the second equation. Or what else can I do in that second equation? That's division, but I multiply the second one by 2, I can subtract from the first. You know what I'm saying? That linear combination thing. So is there a one size fits all? No. Let's use substitution, just because I rarely use it. I figured I'd try it today. If I say that, I can say x is equal to 2 minus 2y. Everybody okay with that? Which means everywhere I see an x in the first equation, what am I going to put? 2 minus 2y. Now, one of the things that most people will screw up here is they'll forget to distribute to the second term, so just make sure you write it out. When you do a couple of these, especially to start out with, it does not hurt to draw your distribution arrows so the way you don't screw it up. So we have what? 6 minus 6y plus 4y is negative 4. Combine like terms, we get what? 6 minus 2y. One of two things here. As you can very well attest, I am a highly positive person. I'm going to add the 2y and add the 4, and I get 10 is 2y. Therefore, y is 5. Okay. If y is 5, what do I do with that to figure out what x is? Yep, very good. Go back up. Substitute back in. So x will equal 2 minus 2 times 5, otherwise known as. Very good. And the only thing you have to be cautious with on these types of problems, guys, is that technically your answer is a set. It's an ordered pair. So your answer should be written as an ordered pair. Negative 3, comma 5. And you're done. Oh, not negative 3, I'm sorry. Negative 8, excuse me. I was adding those two together. All right. Vaguely ring a bell? Bueno, es muy importante para su clase de matemáticas. Sí. Can I go with a clean one? Give you another one? Okay. Go for it. Did you do linear combinations? Did you go? Let's see.